Hello everyone. Today we are going to discuss a topic refraction through prism or deviation through prism. So as you can see on the screen, here we will take a equilateral triangle which is the principal section of a prism. Here we will give the name of this triangle or a prism, that is ABC. On this diagram, this angle A is known as angle of prism. Now we will take our monochromatic source of light, and from this light ray PQ is incident on the surface AB of the prism. So here is the light ray P and Q. So on this point P, on this point Q, that is angle point of incident, we will draw one normal. So here I will draw one normal, and this light ray PQ is entering from rarer medium to the denser medium, so it will bend towards the normal. So the refraction of this light we will show like this. Yes. So now this angle is known as angle of incidence, and this angle is known as angle of refraction. Now this ray QR suffers one more refraction when it will incident on the surface AC. So on the point of intersection, again we will draw one normal. And light ray is entering from denser medium to rarer medium, so it will go away from the normal. So your refraction of a final ray is like this. So this angle we will consider R2 because it is a second angle of incidence. So R1 and R2 we can consider as a same, and this angle of emergence, that is when light ray is coming out of the prism, so this angle with a normal is known as angle of emergence. Now let us assume this prism ABC is not there in the path of incident ray, which is PQ. So what will happen? This ray PQ will follow the straight line path without any deviation, right? So to see this deviation, what we have to do, this emergent ray, that is RS, this we will extend into the backward direction, and here one angle we will get. This angle is known as a deviation angle. Simply deviation means what? Ki the light ray is deviated from its path due to some obstacle, and here that obstacle is a prism. So the angle is made with this original path of a light ray and the refracted path of a light ray is shown the angle of deviation. So here we will complete the remaining diagram. This point of intersection of a two normal, we will give the name N. Here this point of intersection we will say M. So we will get a quadrilateral AQNR. Okay, now remaining angle also we will find out. This angle of incidence and this opposite angle should be the same. Now I want to find out this remaining angle. So how I will find? We know that the angle of incidence and opposite angle of incidence should be same. So we will consider this as x plus r1. So x is nothing but I minus r1. So this angle we can consider I minus r1, and remaining angle we can consider I minus R2. So now this diagram is completed. So we will find out the deviation condition. In the deviation condition, first we required the quadrilateral AQNR. So we know that in the quadrilateral all angles is 360 degree. So in this I only taking two angles, that is angle of prism and angle QNR. So the addition of these two angles is nothing but a 180 degree. We will consider this equation as equation number 1. Now we will consider a triangle MQR. So the addition of the all angles into the triangle, it is 180 degree. That also we know. So that point we will write. So R1 plus R2 plus triangle QNR. So this addition will be 180 degree. This is considered to be equation number 2. Now from equation 1 and equation 2. What we can say, this angle of prism is nothing but addition of R1 and R2. So this is our conclusion. Now one more triangle we will consider. So at this time, the triangle is MQR. Why we took this MQR? Because at this triangle, the deviation produced by the prism is given. So the delta we will find out. Delta is equals to, delta is the exterior angle. So exterior angle is the summation of the interior angle. The interior angles are here MQR plus MRQ. So MQR I can write I minus R1, and this MRQ I can write I minus E minus R2. So we will take a same terms into one bracket. So negative sign again we will take common, R1 plus R2. Now instead of R1 plus R2, I can substitute angle of prism. So just change the side of this angle of prism. So we can say delta plus A is equals to I plus E. This is our minimum angle deviation condition. Okay, so here we can say that if you want the deviation condition, how we can predict this? The angle of incidence plus angle of emergence is equals to angle of deviation plus angle of prism. This is nothing but a deviation condition for the prism. Now we will see the minimum deviation condition. Minimum deviation condition. What is mean by minimum deviation? Whatever the deviation is produced into the refraction of a prism, that we need to minimize. So how we will minimize? For that condition, you have to consider your angle of incidence should be equal to angle of emergence, and your refraction angles should be equal. So I will consider R1 is equals to R2 is equals to R. If you will follow these two conditions, then you can take this angle of deviation should be most minimum value. So delta M you can say. So what is our minimum angle condition? We can say A plus delta is equals to I plus V. So let's substitute the values over here. I can say A plus delta M. Here I plus E is the same. So we can say E plus E, and A plus delta M. You can say I plus I, whatever you can take. But here we require the angle of incidence. So I will take instead of E, I. So A plus delta M is equals to twice I. Just change the side of a 2. So we will get angle of incidence should be A plus delta M divided by 2. So this is our angle of incidence. So in the similar way, we will find out the angle of refraction. So here R1 is equals to R2 is equals to R we have considered. And one more thing we can know, A is equals to R1 plus R2. So just substitute the value. R plus R means 2R. So your angle of refraction should be A by 2. So now I got angle of incidence also, angle of refraction also. Okay. So from this I can find out the prism formula. So for the prism formula, I required Snell's law. What Snell's law said? Sin I upon sin R is equals to constant, and that constant is nothing but a refractive index. So let's substitute the value. I is nothing but A plus delta M by 2 upon R is nothing but sin A by 2 is equals to N, and this formula is known as the prism formula. So here we can say the deviation through prism or a refraction through prism, this point is completed. Thank you.